General design of shutdown valves. Hydraulic actuator. Hydraulic actuators shall be designed, constructed, and tested to meet industry standards. Actuators shall be hydraulically operated, quarter-turn, rotary, single-acting, spring-return piston types, and mounted onto ball valves for ESD applications. The design of the coupling arrangement shall be the responsibility of the actuator supplier. Actuator mechanism shall be of Scotch yoke or rack and pinion types. Lifting eyes shall be provided as required. Upon failure of power or hydraulic signal, the valve shall close. Hydraulic pump motor. The motor of the hydraulic pump shall generate the required pressure in the hydraulic system. Equipped with elements for electrical protection, start-stop facilities controlled by local hydraulic pressure, an on-off switch, local indicators for power supply and availability, and potential free contacts for remote failure annunciation. At least 2 junction boxes shall be provided, one for power connection and one for status signals transmission. Actuator design. Due consideration shall be given to the compatibility between the actuator assembly and the valve based on torque requirements. The actuator maximum output torque at maximum hydraulic network pressure shall not exceed the valve stem maximum allowable torque. Compact actuators shall be offered by the supplier. Hydraulic damping shall be provided to prevent slamming of the valve at the end of the stroke. The design of the actuator assembly shall consider the effect on the valve actuator of being left open-closed for long duration prior to operation and the effect of high-temperature service. The torque thrust characteristics of the actuator in its line application, including static and dynamic pressure effects, shall be compatible with the valve manufacturer's quoted torque thrust curves, taking into account the size of the valve and valve stem characteristics. Actuator mechanical design. Hydraulic actuators shall be capable of driving the valve at a standard speed of 1 inch per second of nominal bore against the maximum differential pressure acting across the valve. The stroke time of the actuator shall be adjustable. The actuator operation shall not be affected by the orientation or position of the valve and actuator. The actuator cylinder and other pressure retaining parts shall be designed and manufactured according to industry standards. Springs. No rubbing or buckling of the springs shall occur. Compression of the return springs shall be limited to prevent sagging or blocking of the spring coils. If multiple springs are used, they shall be mounted to prevent a complete actuator failure in case of a single failure. Spring cans shall have safety features to prevent inadvertent spring release. Coiled springs shall be manufactured and fitted according to relevant standards. Tie bolts bars. Tie bolts bars may be used if measures are taken to prevent galvanic or environmental corrosion. Failure of one tie bolt bar shall not cause the actuator to endanger personnel. In situ replacement of the failed bolt bar should be possible. Lubricants, packing, and access. The actuator internals shall be packed for life with suitable lubricants. Materials. Aluminium shall not be used for any part of the actuator. Brass or copper alloys may only be used for internal parts not exposed to the environment. Buna and rubber shall not be used for any part exposed to gas. Bearings shall not contain aluminium and should be protected from the environment. Materials for control components and accessories shall be 316L SS. Environmental. Actuators shall conform to the local environmental requirements. The spring housing shall be hermetically sealed to prevent ingress of air or moisture. Actuators and their ancillaries shall conform to Ingress Protection Level IP65. Anti-corrosion measures. Protective compounds and durable coatings shall be used to prevent corrosion in case of water condensing inside the various housings, in addition to protecting external parts. Actuators shall be painted according to coating specifications. Nickel plating may be used for the inside surface of cylinders to provide resistance to wear and corrosion. This shall be an electroless coating technique with a minimum thickness of 75 mm. The underlying surface material shall be treated to provide corrosion resistance. Actuator valve interface. The supplier shall be responsible for the mechanical compatibility and provision of mechanical coupling between the valve and actuator. The actuator shall be fully compatible with the valve regarding torque thrust figures, inertial stresses on the valve stem, and mechanical stresses on the valve top works. The actuator shall be mounted on the valve, without overstressing the valve stem. Any requirement for additional support of the actuator shall be clearly identified. The arrangements for fitting the actuator to the valve shall ensure the operating torque is transmitted to the valve without any distortion, overstressing, or slipping of the coupling, mountings, or bolting. The adapter shall be fully enclosed and fitted with pressure relief facilities to prevent overpressure in the event of stem seal leakage. The supplier shall specify any special equipment or arrangements required for mounting the actuator. The required orientation of the actuator shall be as specified in the data sheets. Actuator torque. The torque available from the actuator at any point in the stroke shall be a minimum of 2.5 times the valve torque required to operate a new valve for both the spring closing and externally powered opening, or vice versa for fail-open applications, strokes, including breakaway with the valve under maximum differential pressure and at maximum operating pressure. The supplier should ensure that the delivered actuator meets the required torque output without significantly over-torquing the valve stem, spool piece, bolts, etc. Calculations of the maximum output torque from the actuator, which could shear the valve stem, shall be based on maximum hydraulic pressure and maximum spring force. The datasheets indicate the stroking times to fully close the valve. The supplier shall quote maximum and minimum stroking times at the specified process conditions for the valve and the hydraulic pressure range and ambient condition range specified. The stroking time shall be adjustable between maximum and minimum specified stroke times. The supplier shall provide the torque calculation for minimum, normal, and maximum pressure. Accessories. Shutdown boxes. Local controls and accessories shall be mounted in a shutdown box. Shutdown boxes shall be fully enclosed, 316 SS enclosures separate from the valve, containing all control and shutdown solenoids, manual valves, and other controls as detailed in the datasheets and control schematics. Limit switches. The actuator shall be fitted with 4 limit switches: open, close, 80% open, 70% overrun. The switches shall be closed when the valve is in the corresponding position. Each switch shall operate within 3 degrees of the valve travel from the respective 0 degree and 90 degree limits. The switches shall be of the proximity type and intrinsically safe certified for use in the specified hazardous area. Limit switches shall comply with relevant standards. The open-close limit switches shall be arranged in a common termination box from where a 2-pair cable will be run by others. Flying leads are not acceptable. Cable entry shall be isometric M20 type for the field cable connections. Any unused cable entries shall be plugged. Connection of the open-close position limit switches shall be through a common SS316 junction box, certified. The junction box will contain sufficient terminals to terminate the position switches. Terminals shall be of the clamp type. 1 cable outlet for each limit switch shall be provided. Intermediate position switches, 80% open, shall be provided for partial stroke testing. 70% open indication, test position overrun, shall be provided. Solenoid valves. The solenoid valve shall be of the continuously energized universal type, Class H coil suitable for 24 VOL DC. Body material shall be SS3116. The number of solenoid valves required shall be in accordance with the functional schematics. The solenoid valves shall be provided with a freewheeling diode. The solenoid valves shall be certified and of appropriate type. Solenoid valves shall function on low power and pickup voltage. They shall be provided with a field manual reset. Once the valve is de-energized, the position shall not change unless the manual reset is actuated. The field manual reset shall be tamper-proof. Solenoid valves shall be full-ported, spring-return types. Larger valves may be supplied as required to meet stroking times. Pilot-operated valves are unacceptable. Solenoid valves shall be tubed up so that on power failure, the valve moves to the failure position specified in the datasheets. Tubing and fittings. Tubing shall be of SS316L material. Tube fittings shall be of double compression ferrule type in SS306L material. Hydraulic supply to the actuator shall be sized so that the speed of operation in the fail-safe direction is not limited by the tubing size or the bore of connectors. Tubes and fittings shall be suitable and rated accordingly. The hydraulic medium passages in the solenoid valves shall be large enough to achieve the opening or closing time of the valve as specified. Quick exhaust valves may be considered if required. Local indications. Beacon-type local valve position indication shall be provided. Partial stroking devices are required on shutdown valves as specified in data sheets. Partial stroke testing shall be performed by the control system automatically at a predetermined time. ESD commands shall override partial stroke testing. Partial stroking shall allow partial closure from a fully open position to 20% closure and immediate closure when a shutdown signal is triggered during a partial stroking test. A programming device, if required, shall be supplied. Local accumulator volume tank. Where specified in data sheets, the valve shall be supplied with an accumulator size to prevent valve operation in case of utility supply failure. Accumulators shall generally be sized for 3 complete valve operations or 3 hours of duration, whichever is the greater duty. Accumulators shall be carbon steel, complete with nitrogen precharging facility, lockable drain valve, and pressure gauge. General design of motor-operated valves. Motor-operated valves, MOV, are to be designed and manufactured for operation without jamming, leakage, or deterioration, and to be suitable for installation in the specified environmental conditions. The MOV shall consist of a motor-operated actuator and a butterfly ball valve. Electric valve actuator MOV shall be provided with a smart intelligent actuator with a 2-wire communication network where specified. The intelligent actuator shall be equipped with isolator switches that isolate the actuator while permitting maintenance. Each MOV employs a field unit connected to the master station located in the control room through a 2-wire communication system. The master station shall be connected to the control system through redundant communication. The operation status and diagnostic information shall be available in the control system. The master stations, their power supply, and the communication network to the field units shall be redundant. The field communication link shall not be interrupted due to power loss in one of the field buses. Actuators, which are self-contained package units, shall be used for on-off control operations on an intermittent basis and shall include all electric and control starter components. Each actuator shall comprise a 3-phase electric motor, reduction gearing, reversing contactor starter complete with local controls, adjustable torque limitation facilities, electronic logic controls, and monitoring facilities, all housed in a double-sealed watertight enclosure to a minimum of IP65. Actuators shall be suitable for use on a 415-volt, 3-phase, 50 Hz power supply. If required, the actuator motor and starter shall be provided with heaters to prevent condensation, powered from an internal power supply only. The actuator may be operated from a local or remote location via a selection switch, local remote off. Contacts shall be provided for indication. All electrical terminals within the actuator must be of a firm and rigid construction. All actuators shall be O-ring sealed, watertight, and dustproof to IP65, with an inner watertight and dustproof O-ring seal between the terminal compartment and the internal electrical elements of the actuator, protecting the control mechanism, motor, and other internal electrical elements from moisture and dust ingress when the terminal cover is removed for cabling. The actuator shall be sized to guarantee valve closure and provide sufficient thrust to position and fully stroke the valve against the maximum differential pressure under the specified process and/or startup conditions. The safety margin of motor power available for seating and unseating the valve shall ensure torque switch trip at maximum valve torque with the supply voltage 10% below nominal. A lockable hand auto lever shall be provided to engage hand wheel operation. Energization of the motor shall automatically re-engage power operation. The actuator shall be directly mounted on the valve and include the motor, actuator unit, gears, local mechanical position indicators, phase discriminator, integral limit switches, hand wheel, and electrical starter control as a self-contained unit. The actuators shall be designed for output torques at least 250% of the valve design torque. Operating speed shall be specified on the vendor data sheets. Actuators shall be designed such that in the event of a limit switch failure, The motor shall stop before causing damage to the valve or actuator. The vendor shall provide sizing calculations and the basis of actuator selection for review and approval. Field unit. The field unit shall include features for controlling and monitoring the valve actuator, ensuring proper communication with the master station, and providing necessary diagnostics and operational data. MOV Master Station. The MOV Master Station shall manage the communication with field units, interface with the control system, and ensure redundant power and communication pathways for uninterrupted operation. Design requirements. Motor. The actuator motor shall be designed for valve actuator service with high starting torque, totally enclosed, non-ventilated construction, and suitable for direct online starting. The minimum class of motor insulation shall be Class H with temperature rise limited to Class B above a 55 degrees Celsius ambient. Motors shall be of the squirrel cage induction type with integral protection against overheating. Hammer blow feature. The actuator shall include a lost motion hammer blow feature to allow the motor or hand wheel to accelerate and assist in unseating the valve. Motor control direct online, triple pole, reversing type contactors with mechanical and electrical interlocks to prevent simultaneous closure shall be provided for actuator motor control. The contactors shall comply with relevant standards. Motor protection. The actuator motor stator shall be protected by direct sensing of winding temperature, embedded thermostats in winding to open the contactors on excess winding temperature with self-resetting lockout features. Phase sequence detection. A facility shall be provided to inhibit actuator energization if incorrect phase rotation exists or if one phase is disconnected. Facilities shall ensure correct motor rotation for valve travel direction with either phase sequence of the three-phase power supply connected to the actuator. Short circuit protection MCCBs are provided at the switchgear end. Control features. Local, off-remote selector switches shall be provided and fitted with a key lock to prevent unauthorized operation. The setting feature for all limit and additional auxiliary switches shall include means for checking operating points against valve position without opening the enclosure. The actuator shall have provision for responding to an external control signal for open-close applications. Cabling, wiring, and terminals. Power supply. The MOV actuator shall be suitable for a 415 volts, 3-phase, 50 Hz power supply with voltage and frequency variations within specified limits. Separate cable entries shall be provided for power and control cables, sealed against environmental damage, and fitted with appropriate plugs. The terminal compartment shall protect the actuator's electrical components from moisture and foreign materials ingress during installation and maintenance. The power terminals shall be shrouded from control terminals by an insulating cover. Lifting eyes. Lifting eyes shall be provided as required for safe handling and installation. Handheld terminal. A handheld terminal may be provided for local control and diagnostics of the actuator. This documentation covers the general design principles and requirements for motor-operated valves to ensure reliable and safe operation in various environmental conditions. Quality control, quality assurance requirements. Quality assurance. The vendor shall demonstrate that they operate a quality system in accordance with ISO 9000 series requirements. The effectiveness of the quality system and the vendor's compliance with it shall be subject to monitoring by the purchaser and may be audited following an agreed period of notice. The vendor shall submit a quality control program for purchaser review at the time of tender. The vendor shall provide facilities for and cooperate with purchaser and statutory authority inspectors during manufacturing, assembly, and testing. Inspection and testing. The vendor shall submit for review and approval by the purchaser an inspection and test plan, ITP, covering all relevant components, completed equipment, and systems. The vendor shall allow purchaser access to the fabrication premises for an inspection prior to order placement. A detailed test procedure of shop tests shall be submitted at least 1 month in advance of any testing and shall be approved by the purchaser. The material test certificates, internal shop test reports, weatherproof certificates, X-proof certificates, welding reports if any, etc., shall be verified during inspection. Cold hand stamping is not permitted on carbon steel material. Stamping, if required, shall be by using low-stress stamping or vibro etching only. The entire unit shall be assembled and tested to functionally check the total system operation and ensure minimum commissioning and installation time on site. Actuator testing. The vendor shall devise and execute a test program during all stages of fabrication. Results of such testing shall be fully documented. Testing shall include, as a minimum, perform visual inspection to verify conformity to the specifications data sheet. Where applicable, a check on the dimensions of the finished items against approved drawings for the actuator assembly. Full functional testing, speed of operation, and working of torque limit switches in accordance with this specification and data sheet. The cylinder shall be pressure tested according to the manufacturer's procedures to verify the sealing of pistons and piston rods. Hydrostatic testing shall be carried out on all pressure-retaining components at 1.5 times the maximum working pressure. A check on the nameplate data and tagging in accordance with this specification, data sheet, and drawings. A check on the painting and general suitability for the environment. Factory acceptance tests, actuator valve. The complete valve, actuator, and control system shall be function tested as per industry standards. Functional tests that shall be included as a minimum are speed of opening with maximum and minimum supply pressure, speed of closing under spring load, leakage tests on controls and actuator, stall test to demonstrate that with the valve jammed, the maximum actuator output does not damage the stem and drivetrain, partial stroke test, torque test, brake to fail-safe position. Purchaser's final acceptance of the equipment will be subject to a performance test once the equipment has been installed and commissioned. Such tests shall be held no later than 1 year from initial startup. Routine tests. The following routine tests shall be carried out in the presence of the purchaser or their representative. Circuit continuity checks. Motor and control circuit high voltage test and insulation resistance tests. Performance check on actuator assembly. Torques and motor amps to be checked during light running, stalled, opening, and closing conditions. Voltage drop to be checked also. Visual inspection. Mechanical operation. Response time test. Variation of supply voltage. Variation of frequency. Test on output shaft. Valve testing. Refer to the specification for manual valves and the applicable data sheets. Tower FAT requirements for a MOV master control unit with ICS. The vendor shall carry out the factory acceptance tests for the MOV master control unit and the integration tests with ICS. The vendor shall provide all the personnel, test facilities, equipment, and tools to assist with this. The FAT procedure shall be prepared by the vendor and submitted to purchaser approval at least 2 months prior to carrying out FAT. Vendor requirements. The vendor shall provide the purchaser with at least 14 days' notice to witness tests run in both their shop and their sub-vendors' shops. The vendor shall provide the purchaser with reasonable access to its and its sub-vendors' plant facilities to verify that equipment is manufactured and tested as specified. The vendor shall provide calibration certificates of testing instrumentation for review by the purchaser prior to each test. The vendor shall provide weekly reports during procurement and fabrication phases indicating progress status. The vendor shall provide operations and maintenance training for the purchaser's personnel. This training shall be provided for the equipment supplied, including any sub-vendor equipment included in the package.